I'm Omar Conte, and we are a student from the University of Arkansas, Civil Engineering Department, with an emphasis in geotechnical engineering. And we're gonna conduct unconsolidated undrained test, commonly known in the industry as UU test, as per the ASTM D2850.
First, to get started, what you need are materials. The big material that you need, the main material that you need, is your soil sample. This can be obtained by using a Proctor test, which is D698, or you can also abstract this sample from a Shelby tube taken out of the field. Just to note, this sample must have a ratio of 2 to 1 for the length to diameter. Also, what you need is a membrane, which is such, a membrane expander, and squishy ball. You also need O-rings, which are around these, which is going to go around the membrane to secure it around the sample. Then, along with that, you need a triaxial cell, which is what this is, along with 2 platens, top and bottom. Notice the platens do not have ports for drainage. Since this is a undrained test, you do not need that.
They were using this, right?
Yep, they were. The first one they did, they used this.
After acquiring all the materials and the sample is ready, the sample was measured using a pie tape for the diameter and a caliper for the height to confirm that the slenderness ratio was 2 to 1.
After measuring the height and diameter, the sample was then placed on the base, which has a bottom platen, which is what the sample is sitting on, and then a top platen is placed over the sample. After measurements are required for the sample, the height and diameter, the sample is then placed on the base of the triaxial cell. This base has a bottom platen, which is what the sample is sitting on, and then a top platen, which is placed on the sample. After doing that, a membrane expander was used to expand the membrane so that you can, the sample can be put in the membrane. So. Then the O-rings that are around the membrane expander are then placed on the platens themselves, not on the soil sample. Then the membrane is fixed around the O-rings to give a nice, good, tight seal. Therefore, no water can get into the sample. The cell is then placed around the sample .
Making sure the tubes are not connected to anything because it's an undrained test.
Once that is done, the top cap of the cell is then placed on top, noting that the piston should be all the way up, like such, and locked. The trout line description should be facing the same side as the red valves and the black valves. It is then placed on the sample. The piston is unlocked and allowed to sit inside of the top platen, and then is again locked. Then the thread rods are placed around the sample
to secure the chamber.
to secure the chamber. Finger tight and very tight. And now you're ready to fill the chamber with water. To fill the chamber with water, you take tubing that has this type of connection onto the end, plug it into the chamber, like such, and then turn the water on. This water can be normal tap water, which is what we are using.
After filling up the chamber with water, we bring it to the load frame and we lower the load cell until it's close to the piston but not yet in contact, always making sure that the load frame remains level.
Because this is an undrained test, these valves at the bottom always remain closed.
Before starting the test, the cell pressure transducer and the load cell has to be zeroed out.
To do that, we go to the Sigma 1 UU test software, and you're going to go to, up at the top, you have Setup, Cell Pump, Data Acquisition, and Help. First, you're going to go to Setup. Go down to Sensors. Then over here, you have a sensors list. The external load cell, cell pressure, and pump pressure are all listed. Click on external load cell, click Test, take 0, and OK. Then you're going to go to the cell pressure. You're going to test. To take the 0 of the cell pressure, the pressure transducer nozzle has to be pushed in. You're going to push that in, hit Test, or take 0, OK. And then you are done, so click Done. Once the cell pressure and the external load cell are zeroed out, you then hook them to the cell itself. Cell pressure is at the top, and it's going to measure the pressure that's within the chamber. And then the pump is hooked in at the bottom, which will apply the pressure, or what we call Sigma 3. Once that is completed, we then move over to the software, and we are going to start a new task. So first you hit New Test. This specimen data collection comes up, and you're going to plug in your information. So in project number, Omar and I will put Conte More. In boring or exploration number, we are going to put UU at 15%, because that is the water content that we got for the cell, for the specimen. In sample number, we put standard. Specimen number, this is the first test. The penetration depth is 5 feet, which means later on we will apply 5 psi to the sample. The initial diameter was 2.964 inches. The average initial height was 6.012 inches. We're then going to click Save, and it is going to ask us to save it in a document. We will then name it Conte More 15% UU1, and then click Save. Now that you've gone in and started the new test, you're then going to apply your pressure. You first come up and you click on Cell Pump, and this screen appears. You're then going to do this by pressure control, and in the pressure box here, you're going to click, in our case, 5 psi, because it is at 5 feet of depth. And then we're going to do constant pressure and hit Start Pump. Once you have reached 5 psi within the cell, you are then going to bleed or release some water from the cell pressure transducer to ensure complete saturation. To do that, you take a small Allen wrench, unscrew, and when it starts dripping like that, you're good. We like to say roughly 10 drops and you're completely saturated.
After bleeding the cell pressure transducer, it is important that you do not close the cell pump window, because if you close it, it will shut down the pump. And then very, very carefully unlock the piston and let it travel to the load, so it's in contact with the load cell. That would allow us later to measure the piston uplift force.
Once the piston has been locked again after letting it rise a little to be in contact with the load cell, you are then going to apply a small load to the piston. By doing this, you are going to click the down arrow, the bottom down arrow button, and you're going to click run on and off until you get to that load. Now that the piston has a small force or a small load applied to it, we're then going to click Start Test, and it says unlock the piston and click OK. So Omar is going to unlock the piston, and we are then going to click OK. This now is allowing the test to run. Once the strain limit, the current strain reaches the strain limit of 16% in this case, the test will be done. When conducting the test is run at 1% per minute of strain. Once the strain limit has been reached, the test will then close out the graphs and prompt you to click the End Test button. First, before clicking the End Test button, you lock off the piston, and then you are going to return the load cell to its home position by clicking Go to Home. Once you have removed the cell from around the sample and removed the water, you may then take it back to the table to put into a bread pan and then take a water content on it. When removing the sample from the cell, be sure to extract it very carefully as to not cause any of the excess water that is around the sample to get into the soil itself, therefore by reading higher water contents, and make sure that you don't lose much of the sample itself. Like such, putting it in the bread pan, and then you can put it into the oven and take a water content in 24 hours per ASTM standards.
Thank you for watching this video. We hope it's a useful tool when conducting future UU tests. Go there!